I saw numbers that suggested 71% of Americans are against new data centers in their area.
Yeah.
You can't get 71% of Americans to agree on anything, right? Right? I mean, in this fractious world we have. So that's not good, right?
This is Andrew Chien, a computer scientist at the University of Chicago who studies data centers and the power grid for a living. And when I asked Andrew about the problem, I was surprised, almost stunned, when he said this.
Well, but I'm not sure it's a problem. But
So first off, there's no question Andrew is right about that 71%. That's wild. Most of the country wants nothing to do with data centers. And getting that many Americans to agree on anything is unheard of. And yet, the second thing he said, that he's not sure it's as big a problem as some people think. That's also kind of wild. For sure, the costs are real. We get into the water, the power bills, the small towns pushing back. But some of the people who study this most closely think the story is more complicated than the panic suggests. Hang on to that thought, because today's episode is about the physical body of the AI boom. Every chatbot answer, every AI video, every write this email for me, it all has to live somewhere. And it lives in buildings, warehouses the size of shopping malls, drinking a city's worth of energy, rising up next to small towns from Georgia to Ohio to Memphis. And underneath all of that shouting, there are three honest questions. Is this a bubble or a real shortage? Who pays for it? And the question we'll pull on hardest, does it even have to be built this way? What if you didn't need these giant boxes? What if compute could be decentralized, spread out, flexible, pushed to wherever the power actually is? We'll come back to that. This is The People's AI, presented by the Vana Foundation. I'm your host, Jeff Wilser. Vana is supporting the creation of a new internet, one rooted in data sovereignty, user ownership, and data portability. Their mission is to create a decentralized data ecosystem where individuals, not corporations, govern their own data and share the value it creates. Learn more at vana.org. And we start with a man who saw this coming. Greg Osuri builds decentralized compute. Much more on him later. When we spoke a year ago, he told me AI demand was about to slam headfirst into the power grid. Here's how he describes where things stand now.
Yeah, we predicted the energy, to remind folks, 2024, I think overall data center usage was around 415 terawatt hours. And that was expected to grow to around 980 terawatt hours by 2030. It's about 2.5 times growth. And I think we under-predicted that. The reality looks like, because we tend to take a more conservative approach, the reality is much more worse. And the reality today is most data center projects that were announced by OpenAI, as part of the Stargate program, by CoreWeave, several other players that announced building large data center projects are all stalled because of local community pushback, primarily because of energy. So we're in a crisis beyond historical proportions.
A crisis beyond historical proportions. But here's the stat that really puts all of this in perspective. The demand causing it is coming from a shockingly small number of people. What if that number grows?
If you think, and this is a number I think I cannot get it away from my head because it's so important. So today, if you look at all the users in the world, when it comes to ChatGPT, Gemini, Anthropic Cloud, that use AI, it comes to about 1 billion users. 1 billion users use AI in some form or the other.
I see where you're going with this. I see that there's no amount of humans to compete with the amount of agents out there doing things. I think it's where you're going.
No, not even that. Out of that billion, how many do you think actually use agents?
A small portion now, like less than 5%. Less than 5%, I would guess.
So that's 50 million?
Yeah.
You're way off.
Way off. 0.1%. One more?
It would be like 5 million.
Yeah.
We're way off.
Oh, I'm so curious.
2.4 million.
Okay. So
why that number is important is
that will fucking grow in the future. That number is going to massively grow as people get more.
That 2.4 million is causing the crisis right now. We have crisis of energy with chips. Memory is 4 times more expensive. Storage is incredibly expensive. I mean, things double now. That 2.4 million is causing the current crisis of historic magnitude. What do you think happens when that number grows by order of magnitude? Just 24 million. And that's not even way off, because 24 million is a drop in the bucket, considering there are about 80 million people that know how to code or code some form or the other. I mean, about 40 million professional developers. We're talking about even half the amount of professional developers using agentic coding alone will hit that at 24 million, right? So the numbers we're talking about are at a proportion that that we can't even fathom, because humans are not very good at imagining exponents.
So let me try to help you imagine it, because the numbers here really are hard to hold in your head. This year, the hyperscalers, Microsoft, Google, Amazon, Meta, are spending somewhere between $600 and $700 billion building AI infrastructure. In 1 year, that's more than the entire Apollo program cost, adjusted for inflation. And here's the strange part. The bottleneck is also about electricity. Microsoft alone has reportedly stacked up some $80 billion in orders it can't power. The hardware exists, the juice doesn't. For a sense of scale, one big data center campus, a gigawatt, draws roughly as much power as 800,000 homes. You can't drop that on the map and expect nobody to notice. And the country has noticed. Boy, have people noticed. Protests, we've seen the notice. And Rainie has spent his career measuring exactly this: what Americans actually think when a new technology lands on them. He ran the Pew Research Center's internet research for 24 years. If you've ever seen a poll about Americans and the internet, odds are Lee was behind it. These days, he runs the Imagining the Digital Future Institute at Elam University. He started out as a journalist.
I left that at the turn of the millennium to begin studying the digital life for a big foundation at a think tank. The Pew Charitable Trust gave me a nice grant to begin studying the rise of the internet. And I've been the most fortunate social scientist, I think, in a long time, because I've studied 4 revolutions on my watch. I studied the rise of broadband. Home broadband was just a transformative thing for lots of people. Then the mobile revolution was an amazing thing to behold and changed lots of behaviors and people's ways of doing things. Tied to that very much was the social media revolution, which began in lots of hope, which is a different circumstance now from the 4th revolution that I'm covering, which is artificial intelligence, which has started with a lot of skepticism from the get-go. And I think that's playing out in the environment today.
And Lee is seeing a ton of parallels from his other revolutions to AI.
So at the dawn of the internet, there was a gold rush sense to it. Lots of people were pouring into building websites and web features and clients and things like that. And it was overbuilt. And when all the investments that were poured into putting pet food online and selling it and things like that, the dot-com bubble burst. And there's a possibility here, and I wouldn't venture yet a full prediction on this, but there's a possibility here that data centers themselves are being overbuilt. There's a gold rush sense that artificial intelligence, particularly the language models and the generative AI systems that are now being so popularly used by the general public, there's a sense that there's a lot going on, but there's some possibility, just like in a lot of points in history, that the initial enthusiasm sort of settled down, the business models clarify. I think equilibrium eventually is established, but there's a period when we might be building too much, we might not be building enough, and we're in that sort of confusing period now.
I think everyone can agree there's confusion, and data centers are a big part of this.
There's a big sort of composite picture that's building up now that's sort of centering a lot on data centers. I think that's why it's really smart of you to be focusing on this subject. So at the most proximate level, people are just showing some NIMBY sentiments. They don't want these centers built in their backyards. There are lots of concerns about the environmental impacts, not only just electricity consumption, but water consumption, the impact on local water systems. And so that's the first level. But then it gets wrapped up too in the broader picture about what's AI going to do to us as economic actors and also sort of social actors heading into the future. So a bunch of the opposition that we're seeing, about 2/3 to 3/4 of Americans say they prefer not to have it, at least around them. It's not necessarily a blanket judgment. It's not necessarily saying don't build these things at all. It's just like don't build them near me. But there's a sense too that the future is very uncertain, and so you get this paradox out of it, which is very hard for the companies to figure out.
So I'm wondering though, to what extent do you think that data centers are almost a shorthand or like a proxy for that complicated stew you're describing, and that it's like it's a physical, easy thing to point out and say, we don't want that. Whereas it's far more complicated to think about how do we, in a nuanced, responsible fashion, put kind of guardrails and brakes on the development of frontier models. That's really complicated. What's easy, almost look at like this massive physical thing and say, that's terrible. Don't tear up our parks for that.
Yeah, I think that's a really nice analysis, and I think it's spot on. So there are actually sort of two faces of AI that don't have very popular public perceptions. Data centers are one, and I think the other thing that's going on with data centers, it's part of the stew, is this sense that might explain the paradox too. There's a sense that individuals themselves, when you ask them, is it working for you? Do you like it? Is it improving your productivity? Or you feel like you're a little bit smarter now? Or, they can well articulate the co-creation activities or the cooperative activities they're doing with AI and saying, right now it's okay, it's working out for me. That the other judgment they're making is that the knuckleheads around them, the society that surrounds them, these people aren't prepared and they're not being smart about it. And they're the ones who are falling victim to information wars or hallucinations or mistakes that AI is making. So it's a judgment about sort of broad human capacity to absorb a big hit like that. So the data centers are absolutely the face of some of that. The other face is the leaders at the tech companies themselves. They are getting booed at commencement addresses. They are getting picketed sometimes in their offices. So while there is lots of excitement about them and everybody's hanging on their every word about what's coming next and what are some of the features and things like that, there's a sense that this is a class of people who don't necessarily have the best interests of humanity in mind. And I think there's a vote of no confidence sort of in that, even as people are saying, well, your products are working okay for us.
So the anxiety is real, and for the towns affected, the costs are real and specific. Start with water. In 2023, American data centers drank about 17 billion gallons of it. That was like 3 years ago. Meta's campus in Georgia goes through roughly 500,000 gallons a day, about a tenth of the entire county's water. Now, that said, it's all relative, and others quickly point out that data centers consume less water than golf courses, less water than almonds. But there's also the energy bill, of course. We'll get to the mechanics of that in a few, if this is more nuanced than you think, but the energy costs are real, and so town by town, the country is pushing back. Monterey Park passed a permanent ban at the ballot box. Roughly 14 states are weighing pauses on new construction. New York became the first state to go statewide, freezing permits for new hyperscale data centers. And that brings us back to Andrew Chien, the voice from top of the show. Andrew is not a pundit. He is a system scientist at the University of Chicago and Argonne National Laboratory, and he spent years studying what computing does to the grid. So when Andrew makes a prediction about where this is headed, I pay attention, and his prediction is a doozy.
Well, I think, as recently as 2020, data centers and ICT technology were like 1.5% of the power grid. And I think today we're pushing maybe 4% in the United States, but it's very uneven, right? In some parts of the country, like Northern Virginia, so-called Data Center Alley, it's about 25 maybe 28% of the grid. So there's a few places where it's high. In Arizona, it's getting pretty high. So it's highly uneven across the country. But the best forecasts from the Lawrence Berkeley National Lab reports were a range of going to 8 to 12% by 2028. And they just updated their forecasts, saying that the range should be 9 to 15% by 2030. And their scenarios basically suggest that the most likely scenario is in the middle, right? So maybe 12% or something like that by 2030. Now, my personal opinion is those estimates are low, right? My personal opinion is that we'll be at least at 15% by 2030. And let me say something a little bit more radical. It's my prediction that we'll be at 50% by 2040, which to most people, they say, wow, 50%. But it's already in the forecasts in the areas that have high density of data centers. So in Virginia, they're already forecasting 50%, I think by the early 2030s.
50%. So half the country's electricity feeding data centers within 14 years. We'll get into whether that's consensus prediction. But before we stress test that, consider one piece of history, kind of why the grid feels so maxed out in the first place. And the short version, as Andrew lays it out, for about 40 years, it barely grew at all.
Well, the biggest problem with data centers and the grid is the grid got in the habit of not growing, right? So as an infrastructure, the US power grid basically didn't grow from sometime in the late 1970s, right, on through, maybe 2010 or 2015. And that's because we have all kinds of energy efficiency. So in the US, we got used to not building more generation, not building more transmission on an annual basis. In fact, the only change that was happening in the grid, circa 2015 or something like that, was this transition from fossil fuel-based generation to renewable energy, right, which was solar and wind. And so when all of this demand started to hit, basically the policy, right, meaning the government regulation and the permitting, as well as the utilities' ability to plan and so on, has really not been able to respond quickly enough. It's sort of not their fault. They're not wired to respond to something so fast as computing technology. Computing technology, they basically want it now all the time, right? It's a challenge. So power costs are going up, right? And the reason that they're going up is, when you're inside of a power grid, you have a bunch of different generation. They're so-called the generation stack, right? And the stack is the low-cost power, and then they order it in terms of lower road costs to higher cost generators. And the way that they decide which power to use is they use all the low-cost stuff first. And when you need more, right, then they use the higher and higher cost power, right? So you might say, oh, I'm not that worried because, the higher cost power is just a small fraction of the overall power, right? So it shouldn't affect the price that much. But that's not actually how power markets work. So what they do is they use the most expensive power that was used. So you have this curve, and then you pick the one that was the last one you needed, and that price applies to all the generation. That's called marginal pricing. That's actually how the power markets work.
So the strain is real and the bills are real. The potential environmental impact is real. But remember Andrew's prediction that data centers eating half the grid by 2040. Is that real? Here's the honest answer. Even the experts don't fully agree on the number, like the very measured, thoughtful, respected experts. And to tee up our next guest, I need to come clean about something from my personal past. In the late 1990s, so long ago, it was literally the Clinton administration. I started my career at Intel way back when as a financial analyst. And Intel was co-founded by a man named Gordon Moore. Now, if you know one thing about computer chips, it's probably his Moore's Law. Now, the nerds listening to this are already nodding their heads. For everyone else, the plain version is that computing power roughly doubles every couple of years. There's a quieter, twin or a sibling to that law. For about 40 years, every time chips got faster, they somehow did not need more power. You get the speed for free. Around 2005, that free ride quietly ended or at least slowed down. As for the legendary Moore's Law itself, NVIDIA CEO says it's dead. Andrew Chien says it's dead. Intel says it's just slowing down, but the part nobody argues is about the part that matters. But everyone can agree that the age of more computing for free is essentially over, which means for the first time, more AI means more electricity, full stop. And the man who spent 40 years measuring exactly that, the man whose name literally ended up on the curve, a thing people call Koomey's Law, Koomey, Koomey's Law, is who I dialed up next. This will be Jonathan Koomey of Koomey's Law.
Well, first, I don't call it Koomey's Law, but some people seem to. I focus as one of my main research areas on trends in computing devices and systems. And back in the late 90s, there were a couple of guys running around talking about how the internet was going to use half of all of our electricity. And as part of analyzing those kinds of claims, I decided to spend a lot more time measuring and understanding the energy use of different computing devices. And as part of that work, I started to look into the historical energy efficiency of computing. And I found data going back to ENIAC in 1946. So that was the first electronic computer in the United States. And that was kind of the beginning of the computer revolution. But so I discovered data going back there in terms of the energy use of these devices and the performance of these devices. And from all that, what we got was a trend in the efficiency of computing. And by efficiency, I'm talking about the number of computations you can do per kilowatt hour of electricity use. So it's the service delivered computations divided by the electricity use. And that was the measure of efficiency. And what we found in our study, going back to 1946, was that there was a doubling of that measurement of efficiency every 1.6 years. And that trend continued till about the year 2000. And things started slowing down after that. But that's when people talk about Koomey's Law, that's what they're talking about. It's that long-term trend in the efficiency of computing, that doubling every 1.6 years.
So, John, when you said back then that, okay, the folks who were predicting half of all energy usage by computers in the future, you sensed that would be wrong. And you were correct. You were prescient there. There are now folks saying that data centers will consume in the future half of all electricity. What's your, and one of our guests on the show has, Andrew Chien has made a similar prediction that in years out, that's likely. What's your take? What's your sense of that forecast?
It's very easy to extrapolate into the future. You can do that in some simple ways. And because computing technology changes so fast, people can create these predictions very easily. And it leads to eye-popping numbers because if you take a short-term growth rate and then run it out 10 years, it turns into some, very large increases in electricity use. But that's not how this technology evolves. And I think that anyone who uses simple-minded extrapolation for more than a year or so for computing technology is making a huge mistake. And we can actually look back at the history. So electricity used by data centers doubled from 2000 to 2005. And we know that pretty well because of studies that I did back in the late 2000s. And what happened was the industry realized that there was going to be an issue. It went from about 0.5% of world's electricity to 1% of world's electricity in 2005. And so that was rapid growth, and the industry really focused on the problem. All the chip makers came up with low power modes for their chips, and they figured out ways to make the cooling of data centers much more efficient and a bunch of other things. But they they basically focused on the problem, they improved software, and they ended up slowing the growth from 2005 to 2010. And then from 2010 to 2018, it was very slow growth. It was only about 1% per year. So we started with this very rapid doubling, this 5-year doubling, and then things started slowing down, and then it was pretty flat for a while. Then after 2018, as AI started to pick up and some other deployments of different kinds of computing technologies picked up, there was growth again. But we're starting also from a pretty small base. So the International Energy Agency says in 2024 that compute data centers used about 1.5% of our electricity. So compute data centers include AI data centers. They include all, they include.
But that was, a lot's changed in 2 years, though, right? 2020.
Well, it's true, but it's starting from 1.5%.
Yeah.
So this is the important point: is that just to give you a baseline for where we are with total computing electricity use, compute data centers about 1.5% of the world's electricity, and then crypto's another 0.5 to 1%. So all computing is about 6% in 2024. And so that's where we are. And I think that there's likely to be some growth in that 1.5% compute data center number, but there's no way for that to become half of electricity use. It's just not going to happen. There's too many constraints in the world of atoms.
But even if the demand is real, and it will be real and will grow in staggering ways, can we physically build fast enough?
And all of those things are limited. And what we're seeing is, because of all this focus on expanding power generation and expanding data centers, the lead time for new gas generators is now 7-8 years. And so that means that if you today want to buy a gas combustion turbine even, there's a long wait. And that means it's hard to deploy when you can't get that, right? And it takes a while. Like the utilities, they think in terms of decades. When they're thinking about their system, they think in terms of decades, and it's because it takes a long time to build a lot of this. But what ends up happening in the world of utility forecasting is that there are some pretty substantial problems with double counting and triple counting and quadruple counting the projects, because there's a lot of speculation. So it's pretty clear when the big players make they say we're going to build a certain data center, that there's going to be one of those data centers somewhere. They'll figure that out. There's also a lot of speculators. And what happens is that people get in the interconnection queue. They get some land. They get in the interconnection queue for power. And then they say, I have a data center project. But they, in many cases, do not have a customer for that. They're hoping that someone will buy it. But it doesn't cost them much in most places to get in the interconnection queue. And so there's a kind of incentive for them to say it's a project, because then they can market it. They can raise money and they can try to sell it. And in some cases they will. But the problem is that many of those projects will never come to pass. And there's a great quote from the head of Vistra Energy, who's the second largest independent power producer in the US. And he said, we think these data center projections are overestimated by a factor of 3 to 5, which doesn't mean that there won't be growth in some places, but it means that there's a lot of double counting. And so it's very important for people to understand that if you read the newspaper, you get this idea that, there's explosive growth caused by data centers everywhere. And that is absolutely not the case. So if you look at the actual data from EIA, 2018 to 2023, there was no growth in U.S. electricity consumption. 0. Now that brackets the pandemic, right? So there was a big downward spiral, but no growth for that 5-year period. 2024, 2.1% growth. 2025, 2.4% growth. So there is modest growth kind of moderate growth year to year the last couple of years. But that's not just data centers. Data centers certainly contributed because, as you say, they are spending a huge amount of money, right?
So if demand is only growing modestly in total, why does it feel like such a gold rush?
What has happened historically, number one, they've been giving compute away, right? They're giving it away at well below cost. So of course, when something is free, people like to use a lot of it. And so that's been driving the growth in the service demand. And whether that will continue depends on what happens when these companies start raising the cost, raising the price to reflect the cost.
It's even more explicit for listeners. I think by that you're referring to, for example, in the last 6 months when Anthropic or OpenAI would say for $100 a month, you can do all the agentic stuff you want. And so people were using AI agents and they were gobbling up tokens. And at times, $100 license might burn through $10,000 of token usage. And Anthropic for the bill. And now that subsidy is effectively ending, right? So it's
right, exactly. So they're basically realizing that they have to put some constraints on it and they have to raise the price. And so where that nets out, I don't think we know yet.
The doom is likely overstated. The constraints are real. The bills are real. And somewhere in the middle of all this, we don't know where it all nets out. And there's something else we don't know. And I think it's important that Koomey reminds us of. Are we considering all the costs? Are we considering costs to the environment, additional costs to society? Are we capturing all those in?
Data centers produce computations that are often of great value to society, value much higher than the cost. And that's been true historically. And that's one of the reasons why people keep using more of them, because businesses and people gain great benefit by using computing services to accomplish their goals. The question that we need to be asking is, for any particular application of computing, is it worth it? Are we counting all the costs and all the benefits and doing a real societal tally of whether this actually makes sense? And for most computing up till now, it's been a completely lopsided tally, almost always vastly more value than cost. And I think what we're seeing is there are costs that are not being tallied.
Andrew Chien completely agrees there are costs not being tallied. Because a credible critique of a data center boom was never AI is evil. It's about honesty. It's about, are we cleanly accounting for all the costs?
Oh, gosh. That also we worked on for about 10 years. And the biggest problem is that the data center companies continue to say marketing things that are just not true about their carbon impact. And they've been called on this recently. A whole bunch of the companies claimed they were going to be carbon neutral, carbon zero, all these terms, very misleading. Now it's absolutely clear they're not going to be, right? Because their growth is so fast and they're building so many data centers and their power consumption is growing so fast that their carbon emissions are not going to zero. Now, none of us are happy about, global warming, climate change, and carbon emissions increasing. Having said that, there's lots of industries in the world that generate carbon emissions, right? And the data centers are not the biggest one, but they run the real danger of becoming one of the biggest sources of emissions if they get to that 50% number I talked about for 2040, right?
Koomey has a concrete example, and it's not a subtle one.
There are rules that are being skirted by some of the less scrupulous actors, like XAI putting in a bunch of jet engines, a couple dozen jet engines right next to houses in Memphis. That's one of many examples. There are more responsible operators, typically the bigger ones, right? Amazon, Google, stuff like that. So it's not something that you'd want to put right next to houses. But it's also not, if the power generation is there, then it's much, much more complicated and much, much more impactful. Because really, think about having 24 jet engines near a residential community as XAI did in Memphis. That is just in my view, unconscionable, and nobody should be doing that.
Yeah.
Society's sense of urgency, I think, should be different and less. I do not think we should be waiving environmental regulations or climate goals because the AI folks see it in their interest to build things very, very quickly. I think that we should do this right in a way where these people who claim to be generating huge value or will generate huge value are paying the full costs of their actions. And right now, I think some at least are trying to get away with not paying the full costs. They're just putting in, facilities as quickly as they can, putting in these gas generators without really thinking about the impact on the local community. And I don't think we should be putting up with that. I don't think it's not, and it's more efficient. See, this is the thing, when they pay the full cost, it's more efficient for society because they'll act in a more rational way, and it's also fairer.
Okay, so what are possible solutions? Some that experts such as Andrew have suggested are to kind of change how we're consuming AI and when we're consuming it, right? So just as we're instructed during droughts to use water at certain times or run energy at certain times during heat waves, maybe we can have AI usage during off-peak hours, right? Things like that. And there's definitely parts of the grid when there is excess energy, maybe that excess energy can be used to focus more on AI. But there's also this other idea, other solution for however you want to define the problem, however big the problem is, the idea of decentralized compute. And that gets us back to Greg Osuri and what he is building at Akash. Now, Akash is not the only company doing this kind of thing, but they've been around for a while. Greg has testified before Congress about decentralized computing, and he has spent years on a bet that sounded fringe until roughly this moment. The future of compute is not just a few giant warehouses nobody wants next door, it's everywhere else. Now, I want to be clear, this is not a solved problem and not everyone buys it, but it's also true that it is no longer just on the whiteboard theory stage. As Greg lays out, there is traction, there are users, it is happening. Here's what's already running.
Akash is a decentralized supercloud. What that means is it is a cloud network where the compute comes from places that normally cloud providers don't offer. Places like homes, buildings, small buildings, pretty much anywhere there's compute can be contributed to Akash Network for the greater good. And protocols like Akash are the solutions to this heavy selective biases, which can lead to massive successes, right? So we're very proud to achieve what we achieved. And today, that compute, as it gets more constrained, we're seeing a lot more uses for Akash. Initially, Akash was mostly data center compute, but now we're going into homes with usable compute as well. Homes being one of the best resources, one of the least understood resources, if you think about in terms of energy capture as well as compute capture. Homes are extremely efficient when it comes to energy usage. Latency is a symptom, not a cause. The fact that we all think about latency is because latency is a variable because of a particular algorithmic design. It's not a critical component for training as well as inference. Today, training workloads are evolving to a point that can work on distributed networks, heterogeneous networks, highly fault tolerant. We're seeing companies like Pluralis, for example, training fairly large or usable models on fully decentralized networks that take into latency, that take into fault tolerance and whatnot. But that is no longer the case, and we can have algorithms that can communicate less frequently in bigger batches. HomeNode has been used by a company called Razer, which is a massive hardware company based out of Asia. And they have run a successful campaign during April 1st for image generation on home nodes, which proves that you can actually run these home nodes at scale for a publicly traded company with thousands of employees.
And it's not just gaming rigs.
Most Bitcoin miners, if you look at all the companies, Hut 8, every company that's mining Bitcoin is transitioning to...
They've all pivoted to AI. I've interviewed a lot of them.
Larger setups where you have just simpler deals, but anyone, I mean, if you're not a Hut 8 or if you're one of the big guys, you can simply put a bunch of 5090s, put it on Akash right now and actually earn a sizable income. Your biggest variable will be bandwidth and your energy costs. That's what you got to watch out for. Now, if you have access to, let's say, a solar or renewable, your marginal cost is zero. And that's an incredible incredible opportunity. So it comes down, and your bandwidth, right? And that's another, if you're in a good area, you need internet and whatnot. There's a lot of opportunity there. And that's the beauty of decentralized systems, when you can spread the prosperity and let people go figure out the best way to source compute and energy. That's the best way to build a network. And that's the core thesis of Akash Network, is to, instead of concentrating this compute power in small places, let's spread it across as much as possible. For that, just yesterday, we reached 10 billion user tokens a day. That's quite a lot. It's more than some of the centralized players, right?
Now, Greg has an obvious rooting interest here. It's his company. He's far from unbiased. So I ran the idea past the least invested person in this episode, the pollster. I wanted Rainie's take on the merits of decentralized compute and this kind of approach.
Yeah, that's great. And it's a dynamic that's played out since the earliest days of the internet, when the open source community sort of found its voice and came into its own. I mean, the sense that there are community-based tools, that there are community-based systems that are localized and personalized systems that can come into being. It's a long-standing cohort of folks who are in digital life, and they just sort of carry that argument through every sort of change that's been enacted in the hardware distribution systems. There are ways to sort of carry this stuff in your pocket under the right circumstances. And some of the most interesting stuff that's going on solar capture is basically handing the people the power systems that they might be able to use to run their computer desktops or their phones or things like that. This distributed works in lots of ways. I mean, it's a system that invites self-correction. It invites feedback. It invites diversity. So you've got, almost by definition, more actors with more points of view, more insights, more sort of business acumen on particular parts of things that will play out well for things. So I think, the open side always has things going for it. And, the other thing that's playing out, even as the large arms race is carrying forward the way I described, is there's a massive amount of money to be made in creating systems that are efficient. And the localized systems that do that. They don't have to be the world-class artificial super intelligence models. They just have to do the querying systems, have APIs that work relatively well, that answer your questions adequately and things like that. There's a way in which sort of satisficing in this world, particularly in the spirit of distributed knowledge, distributed systems that can self-correct and work around problems and things like that. It's a hugely compelling story.
It's a hugely compelling story, yes. And to be fair, not a finished one. As mentioned, there are, of course, very real physical advantages to big co-located GPUs all together in a warehouse. That's a real advantage. And different experts have different opinions on how competitive decentralized solutions can be. And let's end with kind of, I confess to John Koomey a bit of my own personal take on this, that in theory, I'm cool with the data center build out as long as it is fully capturing all costs, including the environment. And also, by the way, that we're not like ripping away forests and national parks to do this. And so I'll share here the question, how I gave it to John, and I liked his answer a lot.
I'm in principle fine with the build out, assuming it properly captures all relevant costs, internal and external, and also makes the local communities right. And also, by the way, that it's not ripping away national parks and forests and stuff.
Right, exactly. There's no reason to be doing that. And I think if it really is so valuable, maybe it takes another year or two to build everything with solar, wind, and renewables rather than gas turbines.
Yeah.
And that's what I think we should be putting these on brownfield sites. There's no reason to pave over beautiful landscapes for this. And I feel like part of the problem that we have is a power imbalance, because these are the wealthiest or some of the wealthiest companies in the world, very sophisticated, very smart, and they're approaching local communities that don't have the horsepower. That imbalance troubles me. And so I think that we need to figure out a way that the concerns of local people are taken seriously, and we need to cite these in places where they're not going to wreck people's, quality.
That's a platform I think that would bring everyone together. I could see Elizabeth Warren arm in arm with Sam Altman on converting coal plants to data centers.
If we can get the tech people to stop building the fossil plants, that would be helpful.
But the future, whether people like it or not, is going to include the need for lots more compute. And I think the real question was never whether to build. That's happening whether folks like it or not. It's how, it's where, who pays, and at what cost. And this season of People's AI is about data portability, the freedom to move what's yours. And this episode found the same idea, in a sense, hiding in the walls and the wires, portability of computation. Maybe the most interesting version of this is a future where the compute comes all the way to us. Distributed, flexible, a network of small things instead of a handful of giant boxes nobody wants next door. So after all of these conversations, kind of my takeaway is that, yes, the compute and energy challenge is real, but it's not cataclysmic. And there's hope that it can be done in an environmentally responsible way if actually building out more solar and wind and nuclear and bringing that to the grid. That is not going to happen overnight. Reasonable people can differ on how much energy data centers will gobble up in the future and how quickly they could be built. It seems reasonable, though, to have decentralized compute as a useful piece of its pie or part of the portfolio of compute. Given how big the problem might be in the future, why wouldn't you want that kind of technology as a hedge to give more options? I find it, at the very least, a compelling possibility. And on that note, that will do it for this episode of the People's AI, presented by the Vana Foundation. Thank you to our guests, to Greg Osuri of Akash for making the decentralized bet long before it was fashionable, to Rainie for showing up with 4 revolutions worth of receipts, to Andrew Chien of the University of Chicago for the marginal pricing masterclass and the prediction that started this whole argument, and to Jonathan Koomey for 40 years of measuring what everyone else is guessing at, and for the question this episode couldn't really shake: is it worth it? Thank you again to my partner, the Vana Foundation. Vana is supporting the creation of a new internet, one rooted in data sovereignty, user ownership, and data portability. Their mission is to create a decentralized data ecosystem where individuals, not corporations, govern their own data and share the value it creates. Learn more at vana.org. Thank you to Kate Morgan for research. Thank you to Jasper Chua, our producer, for sound design, music editing, and the videos you'll see on YouTube. Thank you to Bradford Craig for our theme music. And thank you to you, dear listener. If this is your first time at People's AI, please subscribe, share it on social, send to a friend. Thanks again, and see you next time.